Hello friends, welcome to How to Learn channel. This is data engineering stream on How to Learn channel. All right, we saw how to set up Docker on Linux 9, be it RHEL or Oracle, maybe Alma or any other Linux. I guess the procedure is the same. So we saw Oracle Linux on 2 days before, sometime we recorded the video. Now we are moving to the next step, which is to set up the data engineering stack on our lab. You can follow along with me. I am also going to read a blog and I'm going to try follow his blog, set up my lab and see if it works. If it works well, you can also follow that, and you know already that I will be logging the outputs of each of the command. And here is my journal. This video you can use also to reference it, and in case if you see any errors or if in case you see any results deviating from what we record, obviously you will need to revisit your step. Okay, let's start. Uh, you may ask why I chose data engineering. Data engineering I chose because being a DBA for so long, uh, become an obvious choice for me. We are backend, right? We database admins stay behind the scenes, take care of the data of the enterprise. So eventually, the data engineering role is similar to that. So if you compare uh, the stacks in a data processing, a DBA might properly fit in a data engineering role. Same way, you need to store and retrieve your data effectively. That's what data engineering is all means. So we will be participating in data cleaning, data ingestion, data cleaning, transformation, and finally loading back to the storage layer. From there, the data analytics or data science professionals will take the data and work further. So, data science mostly involves mathematician professionals. Data analytics mainly work on the reports for the organization and forecasting the trend. I have worked in data analysis. I have worked in as a database admin. There were a lot of pet projects I was planning to do, but it was already finished by Oracle because they have a separate automation team. So they managed to close them. But I had a lot of pet projects in my mind. I still have few projects. I'm not sure by when I will do it. So, but this data engineering is something that I thought I felt I start because I have like I used to say, um, being a DBA, I got some good amount of experience in SQL. So why not give it a try for data engineering and see if we get some benefits from it. Data engineering is nothing new to me. If you follow my blog, I did my first data engineering project or activity on way back in 2021. But that's also a documentation on. I documented or evidently that I did data engineering. But my journey started a long back before that. Whenever I work in any sort of performance issues on Oracle, that time itself I started my data engineering. I do a lot of historical trend data analysis assessments to evidently identify the root cause of an issue and identify the fix. So here you see, I in my previous project they were setting up Hadoop. So I thought why don't I try it in my lab? So that's how ended up setting up Hadoop in a standalone mode in way back in 2021 itself. That time I was comparing Oracle to big data. I mean RDBMS, traditional RDBMS to big data. How do they fit all these pieces together? How to become the storage layer, the HDFS, and then high query language became the query language, and then there is a optimizer engine separately. There is a metadata engine that came along with the HDFS. So they they fused all those pieces together to process big data. And Parquet was the file format they store, columnar because it's an analytical format of data. And there in a HDFS, I know how they delete a record is they actually load a selected amount of data to a new table and drop the old table and again rename the table. So they cannot do DML so easily. That was one of the issues I still remember. Now, with the latest Databricks, Apache Spark, everything came up. I think it's better I focus on them. And I also parallelly, maybe in a week or so, I'll start Databricks as well. The free tier edition is for lifetime, it seems. And they are offering most of the enterprise grade options, but on a limited scale for our testing purpose. So most probably I'll start reading Databricks as well. I already finished the foundation. That's how I came to know about what is a data lakehouse, and so in Databricks, what are the various stacks, pillars of the Databricks. I've learned about them. The governance mainly they offer. There are a lot of open source data lakehouse or data lakehouse options available, but they're proprietary. The only additional feature that they offer is the governance feature and the AI feature and the ML and AI feature. Genie, they say, right? So I feel those their value addition that they feel could make their product as a selling point, which may be the selling point for the product. But let's start this data engineering. Why I chose this blog? Mainly because I don't want to go to any sort of cloud. I wanted to do practice at my own leisure and add compute and memory as I wish and tune the performance. All that I wanted to do. So if I go to cloud or any free tier edition, I do not know how much I get. They put a condition in the free tier edition in the beginning itself that use it generously because it's been a free edition and I don't want it to be controlled by any of the such options. If I need, I need. I wanted to try consuming it and scale it up. So that's why I thought I was looking for some data lakehouse setup on your local laptop, and that's why I ended up in this particular blog. And he I saw he's running an enterprise as well or a product also, Alex Merker. Let me try setting it up, and he's made any YouTube channel as well. I saw that, so and he in his YouTube video also you will be able to see all this whatever I'm going to blog it here, and thanks to him. So, but I thought, why don't I try practicing this and see if it works? So here you can see, he says specifically we will be implementing a basic lakehouse locally on your laptop with the following components: Apache Spark. Now he's talking about the various components in data lakehouse. So we saw briefly what data engineering is about. Data engineering is the first step in this overall data lifecycle. So data ingestion, cleaning, transformation, and loading. In all these steps, we have data storing and retrieval. So ingestion means you will store the data after you get the data from your pipeline. The incoming data may be a web script data or any feed, any sort of the data that is coming to you. You need to store it somewhere. Then you will do the cleanup. Excel Power Query, you can do cleanup as well. I have read about it. Maybe I wanted to do a video also on that. If you ask me, should I really learn all that? We should not, for me, we should not leave any of the options. We should try to understand all the options, and we need to choose which one among them is best. So we better learn about all these options. So I read about Power Query, yes, and the other cleanup options. You can use SQL also to clean it up. You can use Python clean SQL, anything to clean it up. You can remove the duplicate data. You can drop unnecessary columns. All that are part of the cleanup exercise. And then transformation. You will do some aggregation, and you will compute some additional columns from the already available fields. They all become transformation, and again you load the data back to the target table or the target object. From there the analytics will pick it up and they do it. And so if the data that you offer as a data engineer, if it's not good, the data analytics or data science professionals will fail in their delivery. So data engineer roles become very, very important in this overall data lifecycle. But I wouldn't say data analytics or data science will not be able to predict the quality of the data that you feed. It's their job as well. As you provide the data, as a seller, you sell the data, and at the meantime, the buyer needs to validate whether the product is good or not, right? It's in a buying and selling method. Similar to that, when the data science or data analytics, they also need to validate the data. So it's a two-way validation. So now, like I said, in Hadoop they had multiple stacks. Imagine I will be talking about data engineering in comparison to database admin, because like I say, that's my experience. That's where I have experience in, and it's easy for me to understand the data engineering also in terms of the database administration. It's not each. I mean, mm, if you ask me if can can Oracle or MS SQL provide all the stacks of data engineering? Yes, yes, it does, because they were using SSIS and SSAS and SSRS SQL Server. Oracle provides Apex. You can build your low code applications there directly, and you can do all the whatever you're going to see here and that. But additionally, what you get with this data engineering tools is that which the RDBMS could not do it, which is large object handling, unstructured data handling. But these tools, data lakehouse tools, are good at processing unstructured data as well. When it comes to structured data, you don't need this, I believe, these data engineering tools. No, why? Because already this database, a traditional database does offer all these options already. All you need is an API plugin to connect your AI and ML to this MS SQL and Oracle RDBMS stack, a Postgres stack to get your data out. Even today, I read somewhere Postgres participates in data engineering very well. So, being open source RDBMS stack, people might have developed already a plugin for them. Alright, so I'll be comparing the database stack with data engineering blocks, and I will be able to explain it easily, because the analogy, for me, the analogy will come easily with that. First layer is ingestion of data and streaming of batch data into Lakehouse, Apache Spark. Apache Spark, I read, is an alternative for Hadoop file system. In the MapReduce functionality, Apache Spark became the mainstream. That's a pure the transformation technique. So Apache Spark is the main key component for transforming a large amount of or processing a large amount of data using MapReduce technique. That's a pure the big data systems technique that is mainly used. Multiple nodes will participate in performing the computation of billions or trillion of records. Apache Spark. MinIO is our data lake repository and the S3 compatible storage layer. So Oracle has its own internal engine as a storage, and MySQL, InnoDB as a storage engine. MySQL offers you multiple storage engines. The storage engines are nothing but, I think, is the way that the rows get stored, right? InnoDB in Oracle, it's a heap organized table, and you have temp tables where the data doesn't permanently get stored. MySQL also has a black hole. I read today, where the data never gets stored permanently. So this is a storage layer, MinIO. In this particular stack that we are going to set up, how they compare each other. So in the overall data processing, each step output is going to get stored in this MinIO stack. Next is Apache Iceberg as our table format. How we actually store our records, row wise or column wise. How do you store your data, right? That's Apache Iceberg. That's the format that we want to store. Allows query engine to plan smarter, faster. So the query engines or the optimizer engine needs to know, isn't it? So how is my table recorded? For example, in Oracle you have tables and index, and MS SQL also has tables and indexes. So index access path in MS SQL is much better, always preferred. Oracle had such a scenario way back in 9 when rule-based optimizers were there. So and cost-based optimizer always evaluates which is better plan for me. So query engine needs to know what is it, what is the object model or the object type, or how the data is stored really So they know that then they can draw out an efficient way to actually get your data out. That's the whole idea behind this. So Apache Iceberg as our table format. So the tables are stored in a row wise. So then in order to reduce the number of blocks I fetch, I need to go by row wise operation. So like that. And Nessie is our data catalog. See, in Oracle or MySQL, the dictionary is separate. That's why they store the catalog. Here, catalog is about data. So here, data catalog is stored in another stack called Nessie, allowing data to be discoverable and accessible for our tools, which is absolutely correct. If you run a query, for example, in Hadoop, earlier it used to be high query language (HQL), like SQL, structured query language. So Nessie is the catalog, and it provides Git-like features for data quality. I am yet to explore it as well. As soon as we read about it, we'll read. It's like study with me guide sort of thing, guys. So I'm gonna explain every bit that I read. So even if you're doing any other work, for example, you're taking care of your home or cleaning work or something, you can just keep playing this audio and you can parallelly work. So that's the whole idea. And when the practice session starts, I'll let you know. So you can actually start from that particular minute for your practice session, and you can pause your video and then you can go to the lab and start the practice session. Until then, it will be a pure discussion. Get even more features like an entity UI. Okay, fine. And Dremio will be our query engine. So which we can use performantly query our data, but also document. So this is the optimizer engine also, we can say. So I do not know how efficient this Dremio, and the guy who blogged about it is actually the author of this tool, I guess. So this is very important. The query engine is very important in Oracle. That's why they spend a lot of money in developing the engine. SQL Server is they did the same. So the query engine is the brain behind all the operation, and the optimizer also, you can say, that's one which is responsible for drawing out an efficient, the optimal execution plan, which the query engine will follow and to get it executed. So which can performantly query our data, but also document, organize, and deliver our data to customers, such as data analysts, ad hoc analytics, or building out a BA dashboard. Yeah, so we read about the stacks: Apache Spark, MinIO, Apache Spark for data ingestion, streaming, MinIO storing, Apache Iceberg is a table format. I read Apache Iceberg is it's a bit complicated, complex uh, table format, and I think it's a very recent addition. So anyway, we are going to see how it works. The experience that we carry here will be used in Databricks as well. Okay, Nessie is our data catalog. Is data about catalog. You can literally say that this all are packaged and provided as one component for us for Oracle or MySQL. But here there is no way you're just fusing all these open source tools together. Dremio is our query engine. So like I said in the past, the HQL used to be the high query language, and there's an optimizer up. I remember. Still, it was Spark engine, I believe. I do not remember that time when I was writing about Hadoop. I used to think that there was a separate engine. You can change your storage, the optimizer engines as you wish. You can choose any other engine also you want. I remember that time there were 3-4 engines options available. So, in each engine has its own pros and cons. Here we are going to use Dremio. Let's see how it performs. Even we can compare Databricks performance against our local laptop performance for the same processing. We're gonna get a lot of test data, because you already know I have already got some ATP records. In another video, I showed you how to process a large volume of data. Right? We'll use that data and all for our data analysis. So next, what we are asked to do is to create a Docker container, Docker compose file, and running it. So building a data warehouse locally on your machine requires orchestrating multiple services, and Docker Compose is a perfect tool for this task. This section will create a Docker Compose file to define and run multiple Docker container applications for our data warehouse environment. Alright, so the first step is to install Docker. This is we finished. Second is to create a Docker Compose file. This is the Docker Compose file. I don't understand what the version 3.9 means here, but I will see when we really run this. Based on the error we get, we'll know what really it is. And create a file named Docker Compose. Populate this file with the following content. Navigate to the directory where you want to create the project. So I'm in the machine, and you can see here in Linux. I think it exited. Let it connect again. In Linux, I always keep all these additional tools or softwares on /opt only. You can see already here under /opt. There's already RH and VirtualBox host editions and container ID are already there. Okay, it's broke. Connected infusion. Pause here for a minute. Okay, so here we are. We're on the root, and like I said, I do set up everything under /opt. So optde means an abbreviation data engineer. I'm gonna copy this file. Okay, so let's copy this content. Create the name of the file was docker-compose. Compose.yml. Oh, alright. So you can see this file is now created. Next, so what are we doing in this file? Dremio we are setting up. So we have a container, I think, for that. So we're creating a container for Dremio application. We are plugging in that stack, and then MinIO server, SparkNotebook, and Nessie for our catalog, and Iceberg as a driver. Okay, creating the environment alongside the Docker Compose file. Create a .env file to manage our environment. Start with the given template and fill the details as we progress. Yep, let's start this .env file. I'm doing everything as root here, but it's not necessary you need to do it as root. So since I'm starting now, I'm just using the highest privilege. Later we go, I will reduce the privileges and I will create a separate mount point for them. Next, run the docker compose. So we go into this .env. What do we have? AWS region, and I need to tell you this. This MinIO is an S3 compatible open source product, I guess. You can see here they mentioned about it. MinIO to act as a data log repository and S3 compatible storage layer. So here, this stack overall is more or less aligned with the AWS, I guess. So if you cannot spend money on AWS subscription, because 1 month only you'll get free tier, after that I don't know, most of the services will be charged. Yeah, so the main idea behind I set up everything on my laptop is just two reasons. One, flexibility and freedom to exploit this technology. Second, the limitations with the cloud and the cost. So that you are offered 1 month's duration, and it will stress you on what you learn. And if you learn anything in a month and you don't practice it next month, you will eventually forget it in the third month. So is very challenging. So that's the reason I don't prefer uh, the cloud-based technologies. Doing it from cloud. Instead, we can set up the same equivalent open source in our laptop and learn, and then use the cloud, that 1 month training course as a bridge. Then we will not forget it because you already practiced whatever you're going to learn from the cloud in your local laptop, and you can still have a grasp of it. Okay, so yeah, that's why. So they say AWS region, which is used by Spark US East one. But are we going to connect US East one? No. In multi-region US East one, AWS default region US East one, and AWS access key ID secret key. See, I think all these are these provided by the open source MinIO. S3 endpoint you can see here. Zeros. Nessie is the catalog. So I was reading one YouTube video about DuckDB become the catalog processor, become a catalog engine, and its size was nearly 256 KB for even I don't know, several thousands of objects. I don't recollect. But DuckDB was also used as one of the choices for maintaining the catalog. So go run the Docker Compose. Open 4 terminals for clear log visions. Yep, I need to have 4 terminals. It's not allowing even one terminal. I don't know how many more terminals it's gonna allow me. Okay, the mess here. Alright, I think again I'm gonna face this problem. Alright, I got 4 sessions open. 1, 2, 3, and 4. And I will go to ptd. All the screens I have opened. I will ensure I go here. Similarly here as well. Okay, so it's open. Now let's continue. So open 4 terminals for clear log visualization. Each service should have its own terminal. Ensure you are in the directory containing docker compose. Yeah, we are in that location, docker-compose.yml. In the first terminal, run docker compose MinIO. Yeah, so I need to have this docker compose in my path. Let's see, where is the path? You can see here, this is the RPM. So let's find out its path. It is in docker user lib, and this path is not in my environment variable. I better include everything here. And yeah, docker compose mainly is needed, and this one, but where is it stored? Command line. These libraries user bin docker. So yeah, it's there. User bin is already there. So docker compose is not found. Okay. All right, let's put this in the path. Okay, it's not working. Right. Yeah, it's downloading now. Okay, what was written there? Let's go back and read. The platform MinIO server, yeah. MinIO image 9000 MinIO. All right, let's see. So it's finishing it up. Yes. Container ID. Info formatting. Okay. All right. This is our target endpoint 9000 dogs. Warning. Enable watch. So I think this is done. I can head over to this path. Yes. We need to head over. Before we head over, let me see if really are we listening or not. So yes, this space. Let's see if anything is on 9000 and 9001. Yeah, we have two listeners. Docker proxy. Okay, this is PID. 9000 or 9002. 9000 9001. Okay, so we have this running. So what did he say next? Head over to local host 9000 and browser, log in with the credential. Okay, I will do it. All right. I was setting up my port forwards. You can see here. Head over to here. So I forwarded these ports for now. 9001 and 5000. So, and then I reached out to my local laptop 5000, 9000, 59001, which is actually 9001 on the VM. So now it's asking me to log in with username and password. So is it printing something? Nothing. So like default credentials. Let's try logging here. Yeah, change your password. Okay, license. Now, okay. So create a bucket. So it's an object storage. I think it resembles CS3. Next. So we finished the first one. Now create a bucket called warehouse. So once you're logged in, do the following. So before I do that, I need to document all this. Right. So just give me a minute. All right. So I did my documentation work. Next, let's do that. Next step is to create a bucket called warehouse in the Docker image. So bucket to organize object. A bucket is similar to a folder or directory in a file system. So it's kind of a table space in Oracle database. And same way, file group in SQL Server. So they're asking us to create buckets and hold arbitrary number of objects. Create a bucket. Warehouse. So that's what they're suggesting us to create. Let's create warehouse. Alright, so now we have access is private, created, refresh, create new path. What do you get? New folder name. Okay. I don't know how it will look like really here. Okay, fine anyway. Next, create an access key and copy the access key and secret to your .env file. Create access key. Okay. So you can see here it's a community edition. Let's see how do we do it. How do we create the access key? All right. There is no instruction as to how to create an access key here. Okay, give me a minute. I don't think we have that option in the community edition. The this will look like an additional product or feature, but that feature is not available for the community edition. The access key or access code or access key is not available for us. So let's move on. Let's ignore this for now. Next is Docker Compose up Nessie. So let's do it on the second terminal. So the same place. All right. Okay, we need the same path. So it's working. Let's wait for the Nessie, the catalog to load. It's very easy compared to my previous Hadoop setup. It took me, I think, 2 or 3 days to get it done. All the stack. Okay, it's still getting set up. Just wait for it to finish. How's the load looking on this machine? Yeah, there is a lot of front queue. I'll probably upsize the CPU a bit later. See, the system CPU is also very high. Nothing looks good. See, it's completed the Docker pull and this container, creating the container, and I think Nessie is now launched. Let's go. All right, and the second terminal. In the third terminal, then docker-compose SparkNotebook. Compose SparkNotebook. Again and again, I'm making the same mistake. Okay, so such a large message, Nessie. Alright, I'll go here and run this. SparkNotebook, let it roll. And so we have seen this did not throw any error. This one also did not throw any error. There were some messages here, but it's fine. I think we went past that. It looks like pretty big. the Spark notebook. Okay, that makes me curious. We're on Q7. 16, oh my god. And yeah, all the processors are blocked in the system. And user 99% of the system CPU is done. And see, even it get blocked also. There's no way though. Let's see. Is it done? Oh no, it's still doing it. Okay, so I'll create chapters, guys, so you can easily move forward. I think with this long video. This is the chapter for Spark Notebook, I guess. This is important, Spark Notebook, because this is where we will be writing our Python scripts. Let's wait for it to finish. And let's go back here. Next up. So this is the Dremio, which is the optimizer engine. So we will complete this setup. Then this access keys are not available for us, isn't it? So we need it definitely, but I don't see that in the community edition. Okay, we'll complete this Dremio and then stop it here. From tomorrow we can continue the rest of the document in my next video when I say tomorrow. So then we will see where it takes us to. Waiting for it to finish. I still doing the Docker pull, so you can see here it downloaded a lot. Only 70 to 80% of pull is complete. Rest of them are still in progress. I'll pause the video and I'll continue watching that. Yeah. All right. So we saw that this was the longest step. I said Spark Notebook. So you can see here it just finished it. I took the output. The same version is obsolete. Okay. Now I need to head back to a particular URL to verify if it works fine or not. Is this 127.0.0? I already said I already put a I already. What happens if I just type notebook? Does it give me a soft saying notebook? No. Okay. All right, fine. Let's go to this URL. I already put a port forwarding for 4888888. So I already told you about that. 5888 is our target port. We need to connect 548. So give me a minute. So we're getting to 588888. And you can see why I chose that. This is the actual command we need to connect. 888 token. The token number is in XZ. We just need to connect to that. So just copy this. Go to URL. And you can see here the notebook is created. In the fourth terminal, you need to set up the docker compose. Dremio. So let's go to the fourth terminal. Looks fine. I don't know how big it is. So anyway, let's finish this. path. Alright, it's pulling the Docker image for Dremio. It should finish faster. See, only 7 downloads. Let's see. Oh, it's also a GB. Okay, fine, no problem. Shouldn't take a lot of time though. So the last one is the longest one, it seems. Okay, I'll pass here. So, okay, still it completed the download, but the extraction is taking a lot of time because it's a 1 GB file. I'm going to leave it running for a few minutes and let you know how it comes up. Alright, I think it finished. I'll show you. You can see here it ran through so many steps. I don't know, it's still running. So let's go here. What did it do? It completed the and created the container. It doesn't stop. Oh my god. It's doing some sort of garbage cleanup or something. I don't know. Yeah, pre-evaluate collection, garbage collection cleanup is that. Okay, I couldn't copy this data, but I'll mark it here. My putty log, I can copy it from there. Okay, I got it. Continue. Okay, so let's go to this. So after completing these steps, you will have Dremio, MinIO, and SparkNotebook running in separate Docker containers. Yes, Dremio, MinIO, SparkNotebook. We had 4, isn't it? So we had 4, Nessie also included. So now we need to create a table. Try creating table, but for that we need the AWS access keys, secret key, and endpoint. I think I declared the endpoint. Endpoint is already here. We don't have this option, so I'll research about that for the next step. You don't have any of the options here. It used to be an option here, as far as I read, but it's not there. So I'll read about it and I'll come back to you. So for this video, that's it. It's done. So we have set up Nessie, SparkNotebook, MinIO, Nessie, third SparkNotebook, fourth Dremio. Yeah. So we'll just copy this. Dremio. Yeah. Alright, we'll close this here. Blog and log. We'll meet in the next video. Thanks for staying with me until now, friends. And if you like this video, give me a thumbs up and subscribe to How to Learn channel. And we'll see more videos of this. And if you have any feedbacks, please feel free to share this on the feedback section of the YouTube, so I can take a look at it and then grow from there. Like I said in the beginning of the video, this is learn with me. So first, initially, I'll take a lot of time talking about what I'm going to do, so you can listen to that passively doing some other work, and the lab exercise starts second half of the time, so you can watch with me. And also, I discussed a lot during the lab session also. If you want to passively listen also, please feel free to listen, and put a bookmark for the practice session, so you can directly go to the practice session in the YouTube video and complete it. Thank you. We'll meet in the next video.